If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in permutation combination. So in this lecture we will be seeing what is the basic concepts of binomial coefficients that we have seen in binomial theorem, and prime factorizations and total number of divisors, total number of ways we can represent it as a product of two factors and prime factors, and the concept of de-arrangements and some basic terminology that used from in combination and permutation. Okay, then let's see this. Now this formula we have already seen in case of binomial coefs. I think we have already seen, I have discussed there. nCr, very important property like this. Shortcuts of NC calculation. Instead of calculating 5C3, you can calculate 5C2. Both are equal. You can think of distributing this. 10C3, you can calculate 10C7, you can calculate 10C3. NC0, NCn, that is 1. Now if NCx is NCy, then either x equal to y or it has been distributed. Suppose 10C7, I told you 10C3. How it is possible? Because 10 is distributed in x and y. So x plus y equal to 10. That is x plus y equal to 10. So both these are possible. One more condition, NCr minus 1, conjugative to binomial coefs are there. Then the n plus 1 will be, the God will be increased. The upper one we say God. So God will be increased by 1. If you sit conjugative, then your God will be, if you are sitting side by side conjugative numbers, then your God gets increased by 1. That's it. And this one remains as it is, the higher one. Now NCr is maximum when r is equal to n by 2, when n is even. I told you in binomial coefs also, which coefs will be greatest coef. So if you, the middle one, so if you have NCr, if you have suppose NC2, so you start from 0, 1, 2. So the middle one is 1. So out of, you can think, so 2 by 1 is 1. That's why it is 1. Suppose you have 4. So 0, 1, 2, 3, 4. So middle one is direct n by 2. So middle one is direct n by 2. So if you have n is equal to odd, suppose 3. So 0, 1, 2, 3. Now the middle one, there are two things middle. Either it is n minus 1 by 2, that is 3 minus 1 by 2, that is 1, or 3 plus 1 by 2. Both are same. These and these were equal because binomial coefs you can see these and these equal, these and these equal, these and these attains the maximum. So these and these equal and these both will be equal. The middle two will be equal. So these two will be highest. Either these or these, both will give you same answer. Now one particular question. Suppose n is any number which is written as a product format on factorization, prime factorization, p to the power a, q to the power b, r to the power c. p, q are the distinct prime, a, b, c are the natural numbers. Then total number of divisors of n. Taking 1 and n together. You have to be very careful. If you are not taking 1, then you have to subtract 1. If you are not taking n, then you have to subtract another 1. If you take 1 and n both, because a number is divisible by itself also. Suppose 12. So 12 is divisible by 12. So 1 and 12 both are the divisors of. So if you neglect these two, they have to minus. So what is the formula? A plus 1, b plus 1, c plus 1. So either way you can select. There are 2's and 3's. How many 2's are there? 2. You can select 0, 2, 1, 2, 2, 2. You may select 0, 2, 1, 2. So total you get 3 into 2. So that's why it is 2 plus 1, because you have 3 options. Either you select 1, 2, or additional option you may not select 2 also. That will also purpose. You may select 3, you may not select 0 also. Here no need to neglect 0 because minus 0. Why? Because if you don't take 2 and if you don't take 3, that means you are taking 1. Nothing you have taken means you have taken 1. So that's why that minus 1 part is not done here. So this is the formula. Next is, if you want to find the sum of all these divisors, so you can write it in this format, p to the power 0, 1, 2, then take product. Why? Because if you add this, just in the example we have discussed, it is 28. You may think it is 2 to the power 0, 2 to the power 1, 2. If you take both these, then you are taking 1 only. This into this, 1. Plus this into this will give you 3. This into this will give you 2. So if you take product, these two, all these factors are coming. So if you are taking just adding all this. So this into this is 1. 2 from where 2 into coming, this into this. 3 is coming from this into this. You can see all this. 2 square is coming from this to this. 6 is coming from this to this. 12 is coming from this into this. So how many product, if you take product, how many terms with this you will get 3, with this you will get 3. Total 6. You can see 6. So all these 6 are coming. That's why the sum is 28. The number of ways in which n can be resolved as a product of two factors. So if n is not a perfect square, just now what we have taken 12. So 1, 2, 3, 4, 6, 12. So if you divide it by 2, you can think 1 with 1 you can take a pair 12. So 1 into 12. Because you want to take a product of these two. So how many ways you can write? 1 with 1 you can write 12. With 2 you can write 6. With 3 you can. So for each one you will have 1 in another half. So 2 it will have its counterpart. For 3 it will have its counterpart. So how many ways? 3 ways. Just divide by half. Just to divide it by 2. So you take 1 from that along with 1 come from that side. So For each one you will get each one. So the pair will be half of this one just. So total factors was a plus 1, b plus 1, c plus 1, just the formula A. So divide by 2 if n is not a perfect square. So you see this example, you can apply it here and you can find it 3. So what happens if it is a perfect square? Because if it is a perfect square, total number of divisors becomes odd. If it is not a perfect square, then the number of divisors is always even. So if it becomes odd, then with 1 you can 5, and with this 5 you can 5 another 5 into 5. There are 2 ways. So for that purpose, what you need to do, that's why plus 1, you need to do addition. This 5 you can, because repetition of 5 is possible here in 25. So you can introduce one more 5. So that's why this plus 1 is coming, that factor. The number of ways in which the composite number n can be resolved into factors where they are relatively prime, co-prime. Suppose in 12 you can write it 1 into 12, 3 into 4. So how many ways you can do it? Is 2 to the power n minus 1. N is the number of different prime factors. So what is the idea? Here the prime factors are 2, either 2 or 3. These 2 are the prime factors, 2 numbers. So your answer will be 2 to the power 2 minus 1. Why it is n minus 1 actually? Actually, when you say this one, you out of these 2 you have to leave 1. And then because you have to take 1 only, and then you can do it this one. Suppose if you leave 3, then with if you leave 2, then with 3 you can write 3 into 4. 1 you have to leave because that prime has to come with other numbers so that it becomes co-prime. Because prime number, if you put with another number, there will be no common things between them except 1. So you remove these 2, so it will be 3 into 4. And then 1, you may select 3, you may not select 3. If you don't select 3, then automatically 1 into 12 will automatically come. One thing will come 1 into that number. So that's why prime factors 1 should be left, 1 prime. That's why it is 2 to the power n minus 1. 1 I am leaving out. The others may take or not. So you may say there are 2 options. Either you take 3 or not 3. If you take 3, then it is 1 into 12. If you don't take 3, if you take 3 only, then 3 into 4. If you don't take 3 only, then it is 1 into 12. Now next is dearrangement. Dearrangement is a classical case of a particular case. You remember this case. If questions comes, I will explain how this formula is coming. For now, you remember this one. You have n letters. You have to n letters are there, n envelopes are there. You have to place it there so that no letters goes to no correct place. So if one letter got mistake in another one, then obviously there will be another one. You cannot have one letter mistake because there are 5 letters, 5 envelopes are there. If you do one mistake, if you place one letter incorrectly in another envelope, so obviously one more mistake will be there because it has gone to another one which cannot be placed in that envelope. So that will also goes to this envelope. So there will be no 1 error, 3 error, 4, 5 error. It may be either it will be 2 error, 4 error or 6 or even errors. So you can remember in that way. That's why it starts from 2, and that is some concept of inclusion exclusion methods are there that I have explained in case of function. So remember this one. If n items are placed into n envelopes so that no one is going to in its correct position, then it is de-arrangement. You are not arranging it, you are de-arranging the whole process because you are not placing it at correct place. So de-arrangement formula is this one. You try to remember this one, n factorial 1 by 2 factorial, then minus, then plus, something of inclusion exclusion format. Questions come, I will explain. Now there are some common terms with which you can, students generally get confused which one is combination, which one is permutation. Starting also I discussed. If anything related to selection, choose, distributed group, committee, geometric problem, all comes under combination. Geometric problem means there are 5 points in how many straight lines you can form. All these things are possible using combination. You just select 2, that straight line will be coming. But if they are on same line, then it will not come. Permutation, something related to arrangement, standing, sitting arrangement, standing in a line, sitting in a row, all these are sitting arrangement question. Digit formation, that is number formation, 1, 2, 3 is a number, 3, 2, 1. So you can arrange these numbers or digits so you can get new numbers. Formation of words, letters, you have seen God, Shah's example. Okay, then that's it. If you like the video, then press the like button and please give your valuable comments in the comment section.